Hello, we are Team 7393, the electronVolts, and we are supercharged to tell you about everything we've done this season. This is a brief overview of our hardware, software, and outreach achievements for the year.
To stay organized this season, we set some goals. We plan to train our new and junior members in the engineering design process, programming development, and team management. Additionally, we want to qualify for Worlds through the first Chesapeake Championship. Finally, we wanted to perform 100 hours of outreach directed to the STEM, FIRST, and overall community, which we achieved with 126 hours.
We started this year by hosting a scrimmage 3 weeks after kickoff, which provided a prototype testing opportunity for other teams and us.
The scrimmage showed that the best method of travel was to both climb over the barriers and also zoom through the gaps on the side. So, we built a small robot with Magnum wheels and enough ground clearance to give us great path flexibility.
Our heavy use of 3D CAD aided the implementation of every mechanism into such a tight form factor. We also performed CAD simulation motion analysis to validate our robot's functions. Using this CAD, we also 3D printed many parts of our robot. The 3D printed parts helped us prototype rapidly and gave us more freedom with the design.
At the scrimmage, our one diagonal linear slide proved ineffective at scoring onto the shared shipping hub. The two-axis linear slide system we developed solved this issue and made scoring efficient with its large range of motion. A long horizontal arm can score even across the barrier onto the shared shipping hub, and the vertical arm enables scoring on the Alliance Hub top level.
There's a zone in which our slides cannot move through called the keep-out zone because it would damage components on the robot. To ensure the safety of the robot, we have a path planning algorithm which will move the zones around this area. This prevents both the drivers and the autonomous code from entering the keep-out zone, thus providing a driver enhancement and a key safety feature.
We found the idea for our capping mechanism from a former world record match video online, and we were so inspired that we implemented it ourselves. We thoroughly designed the mechanism in CAD, 3D printed the wheels which extend the tape measure, and manufactured plexiglass side panels using a paper template. Our team shipping element is 3D printed using a spiralized contour to reduce weight by 50% and increase durability by making it more flexible. From designing in CAD to finding errors during assembly, the process of building helps us accomplish our goal of training our new and junior members in the engineering design process.
We find our team shipping element before autonomous starts using a mounted webcam, and the camera is managed with OpenCV, a library used to gather information from images. Our logic we use with the library is outlined in the portfolio. LEDs communicate the state of the position of the element, which is responsive to new data up until the robot starts moving. A large part of our driver control is our unique options framework. It's used for quick modification to the calibration controls or autonomous logic path without changing any code.
This year, we have 4 senior members, so it is critical for us to transfer over our skills and knowledge to younger members on our team. We are training the team juniors in CAD and programming skills. For example, when Mark and I learned CAD with senior members, Lincoln gave us tips and tricks along the way. Let's talk about financing. One way we sustained our team finances is by applying for grants. We got the MSBR grant, which funded us enough that we now run fun workshop outreach activities free for the community.
We achieved our goal of 126 hours of outreach by reaching out to the STEM, FIRST, and general community. An example of our general community outreach is our Robotics Merit Badge workshop. We helped Boy Scouts earn their Robotics Merit Badge by meeting with Scouts in a 2-week time period to build LEGO EB3 robots and compete in a competition we designed. In our 2 times of doing this, we saw 8 out of the 10 Scouts go on to earn this badge and reach out to us about joining our or other FIRST teams. We additionally did live robot demonstrations in the Keystone Truck and Tractor Museum and are now in the works of doing a Sugo LEGO robotics workshop for elementary schoolers.
We also engaged in outreach to the FIRST community. At the beginning of the season, we held a Robot in 3-week scrimmage where teams were invited to rapidly prototype and design a robot in order to participate in the scrimmage and test early ideas. We assisted other teams by doing things like giving a presentation on prototyping to the Clarksburg Coyotes and letting another team, the Spider Bites, practice on our field, as well as giving them general tips. We also reached out to members of the engineering community, like Mr. Chad Parker, for tips on our robot design and notebook. Thanks for watching, and we look forward to talking to you at the Q&A.